Okay, I wanted to walk us through a few extra examples on graphing trig functions. So I picked out some kind of difficult ones here, and they're similar to the ones that are going to be on your lab. So the first one we're going to graph is -4 cosine of 4x plus pi over 4 plus 1. So as you can see, there's a lot going on in this particular function, and we want to make sure we can get it graphed. So what we'll start with is the amplitude. Now the amplitude is always this number in front, okay? It's the A. So we'd have y equals A times cosine of something at bx plus c, which I'll put in there in a minute when we color code, plus 1, or plus d, okay? So the amplitude here would be the absolute value of the number in front. So the absolute value of -4 is 4. And what that tells us is that our function's going to go up to 4 and 4, assuming there's no vertical shift. If there's a vertical shift, then it's going to shift in there. So basically, you've got your midline, and it's going to go up to 4 and down to 4, -4, okay? If it shifts vertically, then it would be something like that, okay? It's going to move up, and in this case, up 1, so it would go up to 5 and down to 3. When I say midline, I want you to know that means where it comes back and it starts your concave down and then concave up, concave down, concave up. So the midline is when it switches between the two. Okay, just want to point that out. The next, the period. So the period is found by using the formula 2 pi over b. And b in this particular function is 4. So reduce that, and we have that our period is pi over 2. So what that means is that we're going to complete a full period, a full rotation of the graph, which rotation meaning the unit circle, or circle in particular, but going up and then back down and back up. So concave down, concave up, or vice versa to complete a full period. And then the phase shift is C over B. So in this case, C is pi over 4, and B was 4. If we reduce that, we get pi over 16. And as usual, inside the parentheses is the opposite. So since it's positive pi over 4, then we'll do the opposite and go left pi over 16. And then we do have a vertical shift. That's D. So it's shifting up 1. The next step is to look at our 5 key points. Okay, so if we take our period, which was pi over 2, and divide that by 4, this tells us how much each point that we're going to graph whether top, midline, or bottom, is going to be apart, okay, on the x-axis. So they're going to be apart, each of them will be apart pi over 8. Now what I do with this is I try to graph it thinking about what the original cosine looked like, okay? The original cosine would start at 0, 1, right there. Well, this one has an amplitude of 4, so that means it would start at 0, 4. However, the amplitude is negative, or the a value is negative 4. It's a negative function. So that means actually our start value is at 0, negative 4. So we found part of our y value, except for also we have to take into account that it's going up 1. So up 1, and we're at negative 3. Okay, so that means that our y value is going to be negative 3. But what about the x value? Let's go think about that. And there's formulas that I give you on the lab that you're welcome to use the formulas. I generally try to think through these things instead of using a formula. That helps you understand more about why instead of just plugging in. But on the solutions of this video that I'm going to upload to Moodle, I will have done it using the formulas in case that helps you. Okay, so where are we going to start? So normally we would start at 0, but this particular function has a phase shift to the left. And the phase shift is at pi over 16. So we need to go pi over 16 to the left of 0. Well, the next thing is, well, where in the world is pi over 16? Well, here's pi over 4. Halfway between 0 and pi over 4 would be pi over 8, right? And halfway between 0 and pi over 8 would be pi over 16. Or, of course, we're talking about negative pi over 16, but you know what I mean. So we are at negative pi over 16, negative 3. Okay, let's try the next one. So, looking back at your original cosine function, the next point would be at pi over 4, 0. Okay, as usual, I'm going to start with the y value. I just find that a little bit easier to start with. So we would be at pi over 4, 0. The amplitude isn't going to affect where we're midline, okay? That only affects the top and the bottom. So we don't have to worry about that 4. We do have to worry about the vertical shift up. So it's going to shift up to 1. Okay? And then what goes next? Well, we said each point is going to be pi over 8 apart. So if you were looking at this using the formula, then you would take your original negative pi over 16 and add pi over 8. But let's look at what that would look like on the graph. So here's our pi over 16, and we want to add pi over 8. Well, what does pi over 8 look like? There's pi over 4, so pi over 8 is halfway. So pi over 8 would be 1, 2, 3 units on our graph, right? So that means that our x value is going to be 1, 2, 3 units from our first point. So that is, we'll have to figure out what that is, but we'll graph it there. And so let's see, what is that? We've got pi over 4, pi over 8. Halfway between 0 and pi over 8 is pi over 16. So our next point is pi over 16, 1. Okay, the next point would have been at pi over 2 negative 1. So what's that going to look like? Okay, so pi over 2 negative 1, it would have been right there. This is yellow, it's hard to see. Let's do it in black. Okay, but we have to deal with the a value. Okay, so it would go down to pi over 2 negative 4. However, because this is negative, it's flipped, so we're going up to positive 4. And then one more thing, factor in your vertical shift, so we're going up 1 to 5. So our third point's y value will be 5. So again, there's two ways that we can look at figuring out the x value. We can take our previous x value, pi over 16, and add pi over 8 to it, because there's pi over 8 between each, and see what that gets us. Or we can go over here and 3 units, because it's pi over 8, so 3 units each time, 1, 2, 3, and up to 5. There's our next point. And what in the world is that? So let's see. We've got, there's pi over 8, right? There's pi over 4. Halfway between pi over 8 and pi over 4 would be 3 pi over 16. Or you can figure that out by adding pi over 16 plus pi over 8. Get a common denominator, 3 pi over 16. Same deal. Now, really, the easiest thing to do from here is just to repeat. Go back down and back up, and you're done. Okay? So, our second blue dot, if we just go 1, 2, 3 more units and keep it at that same midline, there it is. Okay? So that would be, the y value is 1. And what was the x value? Well, we've got to add another pi over 8. 3 pi over 16 plus 5 pi, or plus pi over 8 is 5 pi over 16. And then the last one, go another 1, 2, 3 units, and we're going to bring it back down to negative 3. Take 5 pi over 16, add another pi over 8, you have 7 pi over 16. And you can kind of see from the beginning how this is going. You had negative pi over 16 to 1 pi over 16 to 3 pi over 16. So it's 1, 3, 5, 7. Okay? So now we've got our graph here, and we can make sure it looks like hills and valleys. Don't make straight lines between there because they are not straight lines. Your graph doesn't have to be perfect, but it has to make sense, okay? And you could continue going. Go another 3 units. There we go. But you have to have at least one period graphed. If you want to fill in the whole graph, that's great. And then go another 1, 2, 3, and up to 5. And then another 1, 2, 3, and back to 1. And another 1, 2, 3, and down to -3. And we could even go in the other direction. 1, 2, 3, and up to 1. So that's probably good enough. So there is our first function. And then the last 2 things it asked is, what is the domain? Well, the domain of sine and cosine is always -infinity to infinity. And then what's the range? So let's look over here. We're starting from the bottom, we're starting at -3 and going up to 5. And those are included. So we have -3 to 5. So there's the first one. Let's look at an example with tangent or cotangent. So we're going to graph f of x is equal to -3 cotangent of 3x minus 1. Okay, what's the amplitude? Well, A is -3, yes, but with tangent and cotangent and even secant and cosecant, there is no amplitude because the amplitude is where it stops. And these don't stop. They keep going up and down forever. So, amplitude, none. Okay, period. So let's see, we've got the period for cotangent, and you have to think about your graph. So for your regular cotangent, it starts at 0 and goes to pi over 2. Or no, it goes to pi, okay? So cotangent would normally look something like that, right? Okay? So our period we're going to use between 0 and pi as our parameters, and that will help us find our period. So 0 is less than, and we put bx minus c in here, is less than pi. So tangent would be different because tangent is going from -pi over 2 to pi over 2. And so you would put -pi over 2 is less than bx minus c is less than pi over 2. Okay? The cotangent, we got 0 to pi. And so we plug in bx, b, and c. And all we've got here is 3x. Finish solving this. Don't stop here because this isn't the answer. You have to divide by 3. Split it up if it helps. 0 divided by 3 is 0. Then we have our x solved for, and we have pi over 3. So what this means is that our period, the length of our period is between 0 and pi over 3. The period is pi over 3. So we'll complete a full period in that amount of space. Okay? Phase shift, there's no C here, so no phase shift. Vertical shift, there is a vertical shift. We have down 1. We want to know our asymptotes. Well, we've actually already found our asymptotes, okay? The asymptotes are at either end of that period, 0 and pi over 3. So one is x equals 0, another is x equals pi over 3. And I only ask you for 2 of them because it goes on forever. So I can go ahead and graph those. At 0, there's an asymptote. We're going to graph a vertical dashed line. And at pi over 3, and we'll worry about continuing those here in a little bit. Okay, so all that information is found. Next, what is the point of inflection? Well, if we go over here, the point of inflection for, and what I mean is, let's see, is where it goes from being concave up to concave down again, okay? That's what I'm talking about, in the middle, you could say. That's what I'm talking about as the point of inflection. So, the point of inflection normally for tangent, or cotangent, excuse me, would be at pi over 2, 0. Okay? Well, we've got to move up 1, or no, excuse me, down 1 for our vertical shift. And the point of inflection is always going to be in the middle between our asymptotes. So that means it's going to be at pi over 6, negative 1. It's always in the middle, okay? If you want to do that by hand, you can do 0 plus pi over 3 and divide by 2. Or, like me, you can just look at the graph. So pi over 6, negative 1. And then there's the 1/4 point and the 3/4 point. Well, again, you could go through a lot of trouble and take your asymptote at 0 and add the point of inflection and divide by 2 to find the middle. Or you could just look at your graph. What is halfway between 0 and pi over 6? It's pi over 2, or pi over 12. So pi over 12 will be your x value. What's the y value? Well, it would normally, for cotangent, cotangent normally goes down like this. So we would normally be at 1. However, it's got an a value at 3. So that means our point would be at 3. However, our a value is negative. So guess what? Instead of at 3, we're at negative 3. And did we have a shift? Yes, we had a shift down. So down to negative 4. And then for the 3/4 point, I'm going to just use my graph here. So we have halfway between, what was that? Pi over 6 and pi over 3 is at pi over 4. So the x value is pi over 4. And yes, you could go through the trouble of saying your inflection point plus the right hand asymptote and divide by 2, but That's a pain. Look at your graph. Okay, and so we would, let's see, we would be at 3, but we've moved down 1, so we're going to be at 2. Okay? And so now we can graph it. And it is not a straight line, okay? So be careful. It goes up like a U and down like an upside down U, okay? And then from there, we can go ahead and repeat it if we want to take it on out. That was 1 period, so that's all you have to have. But another pi over 3 would be 2 pi over 3 for the next asymptote. And I don't think I can fit the other on there. Okay? So I could fit... Oh, no, the next would be at pi. Sorry. Okay? And then I can take my point of inflection and just move it over to the middle, keeping it at -1. And then in the middle, between the asymptote and the point inflection, keep that at -4. And then same thing, but keep that top one at 2. And so there are 3 periods of this tangent curve. What are the domain and range? Well, the range is always negative infinity to infinity for tangent and cotangent. We've got to determine the domain. Okay, so the domain is going everywhere. Like this will keep going down and out. This will keep going up and out, okay? So all these values except for the asymptotes are being accounted for in the domain. So that's why I've got it written here kind of weird like. All real numbers except every, and how far is it between each asymptote? It's a period. So we're going to plug in the period here. So except every pi over 3, beginning at, here we're going to put an asymptote. Okay, so every pi over 3, beginning at some asymptote. I'm just going to pick the first one we have graphed. We don't have... I mean, if you don't pick the exact same one as me, as long as it's an asymptote, that's fine. So we're beginning at x equals 0. Okay, that's a tangent one. This is getting long. You see why I didn't think we'd have time to do it in class. So, one more. We're going to do a secant or cosecant. And so we have... f of x equals 2 times the cosecant of x plus 1. Now, cosecant is the, I say opposite, but that's not really true. I say inverse, but that's not really true. But it's the flip, if you are looking at identities, of sine. So what we're really doing here is we're really graphing 2 sine of x plus 1 and then doing some flipping and adding asymptotes, okay? So we're just going to focus on graphing 2 sine of x plus 1. What's the amplitude? Well, there is no amplitude. Yes, there is an a value. It's 2. But there's not actually an amplitude in cosecant and secant. What's the period? Well, it's the same as we would do with sine, okay? So the period is 2 pi over b. And in this case, our b is just 1. So our period is 2 pi. What's the phase shift? Well, the phase shift would be c over b. C is 1, b is 1. There is no phase shift. Or b is 0, c is 0, b is 1. So no phase shift. And then there is a vertical shift we put here, and it is up 1. Okay, so let's focus on graphing sine here. So we have to go through the 5 key points again. So we'll take our period, that was 2 pi, and divide by 4, and gives us pi over 2. That's how far they're going to be apart. So our first point for sine would normally be 0, 0. And there's no phase shift, so the x value is still going to be 0. But we've gone up 1, right? So we would be at 0, 0, but there's a vertical shift taking us up 1. So our first point is at 0, 1. The second point for sine would normally be at pi over 2, 1. And since the period of this, and there's no phase shift, and the period is the same as the period of normal sine, then, and this period divided by 4 is pi over 2, then we're still at pi over 2. So it would normally be at pi over 2, 1. However, our amplitude is 2, so we've got to go up to 2. And also, our vertical shift is up 1. You could also think of that as from our midline, we had to go up 2, right? So it's pi over 2, 3. Our third point would normally be at pi 0. It's going to be at pi 1. Notice I'm going back to that point, or that y value. So pi 1. There we go. And then the fourth point would normally be at 3 pi over 2, negative 1. It's going to be at 3 pi over 2, and we've got to go 2 down. So it'll be at negative 1, actually. And lastly, we would have 2 pi 0. This one's going to be at 2 pi. But we've got to go back to our midline. So 2 pi 1. Okay? So there's our 5 key points. So here is sine. And I'm graphing this dashed because it is not part of the cosecant graph. And if we wanted to continue, we could here. 4-bit. Okay? So, where are the asymptotes? Well, the asymptotes are at the midlines. Okay? They're the x values of the midlines. So we're going to have one at 0. We're going to have one at pi. We're going to have one at 2 pi. And we're going to have one at 3 pi. And we only need to list 2, so I'm going to list 0 and pi as my asymptotes. And then last, we need the domain and range, but we got to graph this thing first because it's not officially graphed. So to graph cosecant, we're going to flip. Notice there's a u here. Well, instead, we're going to make a u going up the other direction, and it's actually going to continue forever up. And then there's our u that's going to flip and go down. And then this u will go up. Okay, so you have to have at least that much for a full period, just so you know. But to fill in the rest, that would go up. And this piece right here would go down. Okay? And you can go back and erase Sine if you like, just to be official. But if you don't erase it on your graph, that's fine, as long as you've got it dashed. If you don't have it dashed, I'm going to think you mean it's part of your graph. Or if you do it in a separate color, like if you do the Sine in a lighter color like I did, and then go back with the cosecant in a darker color, that's fine. But make sure that I can see that you knew there was a difference there. If they're both solid, in the same color like this, then I'm going to think you thought it meant to be like that. Okay? So what is the range now? Okay. So, we can start with the range. Okay, so the range is everything except for in between, because these points aren't here anymore, right? Everything except for in between -1 and -3. So it's going to come from below -1 and then go above 3. So the range is -infinity to -1, including -1. Because it's included, right? It's a point on there. Unioned with 3, including 3, to infinity. And then last, the range. So it says all real numbers except every half period. Well, if you read this, half the period, that's 2 pi divided by 2, right? So pi. All real numbers except every pi. And if you look at your graph, you can see why that is. There is pi. Okay? So it's all real numbers except this here, because we're going in between the asymptotes. And so there would be another pi, and there would be another pi. Beginning at the first 0 of sine cosine. So the first 0 was right here. Or, yeah, that's technically not, the 0 would be like somewhere in there. That's technically not correct. It's actually at the first asymptote. Okay? At the first asymptote is what that should say. So the first asymptote would be 0. It would have been the original 0 if we hadn't moved it up or down any. Okay? It's hard to say that. Okay, well, that took forever, but we are finally done, I believe, with our 3 graphs. And hopefully, if you needed this, then you've watched it and it's helped you more with that third lab.